All right, my name is Lindberger, and I'm going to talk to you about NixOps. So first, a little bit more about me. I'm from Stockholm, and I'm a board member of the hackerspace X, and I'm a NixOS user and a contributor since about 2017. And I'm an IT specialist at Excellent Audio, where I try to use as much NixOS and NixOps as I can. All right, so the agenda is what does NixOps do? How does it work? Why would you choose NixOps? And then a little bit about the future of NixOps. So what does it do? NixOps deploys NixOS system configurations to remote machines. And deployments are declarative and entirely written in Nix. It can deploy configurations to existing machines that you've set up manually. And it can also provision new machines, such as VirtualBox virtual machines and AWS EC2 instances and Google Cloud Engine instances and more. It can also provision non-machine resources such as SSH keys and subnets and S3 buckets and DNS records and much more. It also handles multiple networks and clouds in the same deployment and can set up encrypted tunnels between hosts. So first off, what is a deployment? A deployment is the unit most operations in NixOps act on by default. So some commands you can specify that it should act on a part of a deployment as well, but by default most commands act on a deployment. And it contains servers and resources that should be deployed together. Everything put into one specification. So let's look at how such a specification is built. So say we have the following NixOS configuration, which, well, just starts Nginx to host the NixOS manual. And yeah, the configuration is pretty simple. Just enable Nginx and create an example virtual host. And in that we set the root to be the path of the NixOS HTML manual. So when you go to this, you will just see the HTML version of the manual. But we want to deploy this using NixOps. The first thing we do to construct our deployment specification is to wrap this in an address set and set it to the node, the name we want for the node. So just simply call this web server, and the rest of the configuration is exactly the same as it was in NixOS. And then we also have to specify where we want to deploy this. So if we want to deploy to a machine in our local network, we can specify that by setting deployment target host. And that we can set to either a host name or an IP address like this. And then NixOps will SSH into that machine and apply the configuration there. But that means that you have to have set up an environment on that machine that NixOps can actually control. But before we deploy to a production environment, we can test it out by deploying to VirtualBox by setting deployment target env to VirtualBox. And this will with this, NixOps will just create a VirtualBox VM and deploy to that. So you can test it out locally before actually deploying to a production environment. So creating a deployment. To use that configuration that I showed you, we need to create a deployment in NixOps. And we do this with the command NixOps create, which creates the deployment, but it won't actually deploy anything. So it just creates all the metadata that is needed so that NixOps actually knows which files belong to the deployment. And this only has to be done once. So when the files we feed it changes, NixOps will automatically pick that up. So let's just show you how that works. Oh, right, sorry. I'll increase that. Is that better or
more?
There?
More contrast.
That's a bit harder, though.
That's good.
I think this might be a bit too much. Is that okay? Can everyone see? Okay. All right. So that's pretty much it. Like, we can now check the info, but yeah, it doesn't do very much yet. It's just like we've told the NixOps that there is this file called webserver.nix, and that's pretty much it so far. So to actually deploy anything, we use the command NixOps deploy. And every time we make a change to our configuration, we need to run this command for the changes to take effect. So during deployment, NixOps does several things. It first checks the state to see whether all declared resources have been provisioned already. And if they aren't, they're provisioned. In the case of a machine, it's instantiated, and NixOps waits for SSH access to the machine. And then when it actually has access to the machines and everything is set up, the configuration is built, and the closure of the configuration is copied to the server, and then it activates the new configuration. So let's show you that. Just do that. The forced reboot you can essentially ignore. It's just because I know this is going to fail. It starts by setting up a new disk image here, the VirtualBox VM. And there we go. So we can watch it boot if we want, but I'll switch back to the terminal. And then it's waiting for an IP address from the VirtualBox, so I can communicate with it. Right. And this takes a little while. I don't have the fastest machine either, so. Come on. All right. And now it actually has access. So it's building the configuration, and the configuration is just the one I showed you previously, the NixOS manual Nginx server. And now it's copying all the built packages over to the server, or the configuration closure. more than expected. All right, it's finally finished. So now it sets up grub, and instead of activating this configuration, it reboots the machine, because I know that it tries to restart the VirtualBox guest VM extensions, and that's going to fail, because for some reason, I guess they're too new, or the version jump was too great or something like that, but just rebooting the machine solves that. So the configuration is, it just works, but yeah. I guess it needs a new kernel or something like that, and then we can actually go to this machine. I can now run the NixOps info again, and then, oh, well, that looks a bit wonky, but but yes, normally it would be a nice ASCII table, and you can see the IP address of the machine here. So we can just go to that IP address in our web browser, and we have the NixOS manual. Yay! Right, so that was the, well, simple demo there, and we can shut this down, or actually we can destroy that machine, because I don't need it anymore. All right. But we can also do split deployments. So in the previous one, we had everything specified in one place. But actually writing everything in the same place as the NixOS configuration, the physical specification, it can get pretty messy and hard to maintain for anything slightly more complex than the previous toy example. But luckily, we're not limited to one specification file. We can use however many we want. And NixOps will just read from all of them and merge the definitions into one. So, for example, to achieve the previous example with a split, we can have just one file with the logical specification, which is essentially just the NixOS configuration. Like, there's not much more in it than that. And then we have the physical specification in a separate file, where we just assign the same name for it in the attribute set, so web server, just as we had for the previous one. And yeah, that works just the same as the previous example. We just have to tell NixOps to look in both of these files when we create the deployment. And yeah, this means that we can actually reuse the logical specification in multiple deployments. So, for example, we can create a production deployment, and that has our logical specification here and the physical specification that we want to use for, say, Amazon AWS or something like that. And then we can have a separate deployment called testing, which has the previous ones that I showed you, where we have just a VirtualBox or something like that. And when we change the the logical specification, we can just deploy to testing first, see that everything works, and then we can deploy the production when we've made sure that everything works as it should. So, and we can also easily reuse any host specification within a deployment, since it's all Nix. So we can just assign the configuration innerlet and then set multiple attributes to that same specification. So this one would simply create two web servers called web server 1 and web server 2, and they have the exact same configuration, both of them. We can also set up communication between hosts, or rather NixOps does this by default. So by default, all the hosts in a deployment can refer to each other by name, since NixOps actually updates the etc host file for us. So if, for example, we want to put an HA proxy in front of our web servers, the config file could look like this. So we just refer to web server 1 and web server 2 by their name, and yeah, NixOps has set up the host file so that those names point to the IP addresses of those hosts. But we can also set up deployment encrypted links too, and that will make NixOps set up encrypted tunnels to the specified hosts. So it automatically creates encrypted tunnels both ways between the hosts. But you specify that on one of the hosts, and for example here we have an example deployment with where we want to use HA proxy in front of the web servers, and then in the logical specification of, or possibly the physical specification of the deployment, we specify that we want encrypted links to the two web servers. And NixOps then creates the two encrypted tunnels, and they will be called like web server 1-encrypted. And we can connect to those tunnels on port 80, for example, and that will automatically encrypt the traffic between the load balancer and the web servers. All right, and an important thing is also to be able to handle secrets, which in NixOS is kind of a tricky thing at times. But yeah, specifying secrets as just normal strings in NixOS is not really a good idea, since they will be put into the Nix store in world-readable plain text. So anyone on the machine, no matter what user privileges they have, can read that in the Nix store. So, for example, yeah, we have this, just a database password, and anyone can read that. Instead, we often want to use paths. We want to put in paths to files outside of the store instead, which actually contains the secret. So the only thing that will be stored in the Nix store here is the path /var lib gitlab db password. But then we can set permissions on that file so that only the service that should read that file actually can read that file. But so that's all fine when we do it in NixOS, because then we have access to the whole file system and we can create those secret files there. But how do we do that in NixOps, where we just set up a machine and then it's supposed to be running without any user interaction? So in NixOps, each deployment can define a special attribute set called deployment keys, where each attribute corresponds to a file which will be placed outside the store on the target host. So, for example, we have deployment keys SSL cert here. So I want to push an SSL certificate and private key bundle over to the host. And so I specify the local path to that file and then set permissions so that it's only readable by the owner. And by default, that is keys, or I think the owner is by default root, and then it's readable by the group keys, or something like that. But yes, with all of that in mind, it's time for a more advanced example. So in the following demo, we'll set up a deployment with 2 web servers and a load balancer. And the web servers use the same logical and physical specification. The load balancer uses the same physical specification as the web servers. The load balancer communicates with the web servers through encrypted tunnels. And it's all deployed to a new VPC on AWS. So let's see. So I'll just show you how this configuration looks to begin with. We can start with the logical specification. And I'm going to adjust the font size, so don't worry. Is that readable, or do you need it bigger? Bigger. Oh, yeah.
More contrast.
Is that? Yeah. Well, get me a better projector. All right. So first off, in the let here we define web server. And that is pretty much, it's more or less the thing I showed you previously. And then we have load balancer, which just takes where I've just specified that we want the SSL certificate, private key. And then in the HA proxy configuration here, we actually get the path to that file when it's pushed over to the server by using this attribute config deployment keys SSL cert path. And then HA proxy also needs to be a part of the keys group to actually be able to read this. And that's pretty much it. So yeah, and the web servers are just, so web server 1 and web server 2 are just set to web server, and then we inherit the load balance and config. Then the physical specification here. Is that, no? All right. So here is where it gets a bit more complicated, where we first have to define an access key so that NixOps can actually use API calls to Amazon. And then we specify a region and a physical specification for a PHP host here, which, we just set the target env to EC2 and specify which AMI, which disk image it's supposed to use, and instance type, how much disk space, and a few security groups so that we can actually access it, and a few other things. But let's move on. So much of this is fairly boilerplatey, I would say, but we specify that we want it to generate a new SSH key pair here, and then create a VPC called example VPC, and a subnet to put the host in, and here we have the security groups, so just one security group to open up HTTP access, so port 80 and 443. And then we have one that opens up SSH access to the hosts, which is needed for us to be for NixOps to be able to access the hosts once they're set up. It doesn't have to be public access, of course, but well, we have to open up SSH to the hosts so that we can access it at least. Then here we have just route tables, which this is very boilerplatey. Just open up, connect the subnet to an internet gateway so that we have internet access. And yeah, a lot of this you don't really need to care all that much about, but yeah. I'll be putting up the configuration in a repo afterwards, and the slides and everything, so you can take a look at it if you're interested. And I've tried to comment some things here, at least, where it might be a bit fuzzy. So we also define an elastic IP, so that we then assign to the load balancer. And so that means that we can move the elastic IP from host to host and keep the same IP address, even though we, for example, shut down one server and then just allocate it to, like, set it to a new server. So we don't even have to update DNS. All right. And yes, so for the load balancer, I guess is the more advanced physical specification, but the only thing that is new from the PHP host is that we specify deployment route 53, which is Amazon's DNS service. And I've specified that the load balancer should get the DNS address oslodemo.xlnaudio.com. So I'm going to deploy this to our work, to my
Production environment.
yes, no, not the production environment. One of the reasons I'm setting up a new VPC is I want this to be really firewalled from anything production. But yeah, I'm using my work environment to do this. So yeah, I guess thanks to Excellent Audio for letting me do this. And right, then we can switch to the terminal again. And we'll create this deployment. Oh, okay, well this is, yeah. So just specify the two files I just showed you here in the deployment instead of the other previous one. And I create a deployment called AWS demo. So that's it. And then run NixOps deploy. And let's hope this works. All right, so it goes off there, creating the security routing tables, and yeah, a lot of, goes pretty fast. Okay, so we created the instances, and it's waiting for SSH. All right, here we go. Yeah, while this is working, I can tell you about some other interesting commands. So, for example, NixOps has a command called SSH, which simply SSHs into the specified machine in a deployment. So it's very handy if you want to troubleshoot stuff, and you don't have to keep track of IP addresses to hosts, since NixOps does that for you. So just specify the name and then you're in. And yeah, I showed you destroy, so that just takes down everything in the physical specification of a deployment. So yeah, deletes the VirtualBox image or deletes all the instances in Amazon or such. And yeah, start and stop. Pretty given, like just start all the machines in a deployment or stop all machines in a deployment. But then most operations also let you specify -- include or -- exclude. So if you only want to run this on one host, so say you want to destroy one host in an environment, you want to take down that specific server, then you can do like destroy and then include and then the name of that machine. Or exclude if you only want to keep one machine or two machines, but I guess that's probably less commonly used. All right. Okay. Well, it's still going, but still copying the closure. Yeah.
So
In a moment.
does it
Yes.
copy the files from your local machine or from
Yes.
or
Yeah, it builds everything locally on my machine first, and then it just pushes all that up to the server. So yeah, okay, well now it's done. So let's see, we should be able to access that on Oslo demo. Yeah, I have it there already. And there we go. Not very exciting, but yeah, still just the same thing. It's but deployed in a very overkill environment with 2 hosts and a load balancer and encryption between the hosts. So yeah, no need to keep that around. We can just destroy it. Yeah, it's fine. All right. Oh yeah, I guess that might be a bit interesting when it just shuts down the machines first and then just, yeah, removes everything. So if you look in the control panel afterwards, yeah, you see pretty much no traces of ever having run this, which is pretty great for testing. All right. And then, yeah, so why would you choose NixOps? Well, because of NixOS. So one of the main reasons, I would say. So all configurations are built locally before being shipped off to servers and applied. And if there's any error in building any configuration, the whole operation is just aborted. So yeah. And when a configuration is activated, it's pretty much an atomic operation that can be rolled back. Just as, yeah, this is just NixOS stuff, really. And configuration files aren't updated in place. So in contrast to other like imperative deployment systems, such as Ansible, which I tried using before, they often make in-place updates to configuration files. So you specify, like, yeah, go into this file and then make these changes. Yeah, that might break. Idempotence often has to be manually implemented in recipes in those systems. So checking whether I've already done this update for every step in a recipe, like, yeah, have I already updated this configuration file? Does it contain what I want it to contain? And that often has to be implemented manually in those, so that we know that we don't make a change twice and break the configuration. And when the system is updated, configuration files that are part of the OS or part of a package, they may not be updated depending on the current state. So, for example, if we've changed it and we use Arch, Pacman wouldn't update the changed configuration files to the version that is actually in the package. And maybe we specify in our configuration that, well, we sort of depend on all hosts having the latest version of that package, and we want to make a change to a configuration file that looks exactly like that, like in that package. And then that would break if we have a mix between new and old hosts. And if an error occurs during deployment, we're often left with a half-updated system. So this happened to me all the time with Ansible, where it just managed to run many of the steps, but not all, and then just aborted. And I was left with some, a half-updated mess where it got to update some configuration files, but not everything that was needed, which not very fun. And also, because it also does provisioning, is one of the big things, to me at least. I use that a lot at work. So setting up and tearing down Amazon networks, and actually describing, having a good description of the network in one place, and not having to dig through the Amazon configuration panels, which are 100 levels deep until you actually find what you're looking for. And so on to the future of NixOps. And I don't know super much about the future of NixOps, but I know that there are ongoing efforts to port NixOps to Python 3, and it's currently written in Python 2, unfortunately. So hopefully we'll see that soon. It's a bit late to the party, I guess, since Python 2 support is now officially dropped. Right. And also upcoming is that the backends, the AWS, GCE, and all that, the physical deployment backends, will be split into separate plugins in an upcoming release. So this is already done in master, but there's no released version yet where this is the case. So all the plugins will in the future be placed in their separate repos, and or all the backends, I should say. So they implemented a plugin infrastructure rather, where I guess the reason for this was to make it easier to write your own plugins and maintain them separately, because previously everything was just in one big repo, and there were a lot of forks with different backends, and some of them got merged and some of them didn't, but people used those backends anyway. So all right, so then on to a summary. NixOps deploys NixOS system configurations to existing machines that you've set up or newly provisioned machines. It can provision both machines and non-machine resources. And NixOps owes many of its selling points to NixOS. And that's pretty much it. Any questions? All right, Alex, I guess?
Yeah, so have you used Terraform? And is it better or worse, or just different?
So I'll repeat the question. So the question was, have I used Terraform? And is it better or worse than NixOps? No, I have not used Terraform. I've read about it, and it seems interesting. I guess one of the main pros of Terraform would be that it's a very much more active project. So the backends are actually maintained probably quite a bit better than in NixOps. And So maybe a potential future for NixOps would be to actually, or any alternative to NixOps would be to actually wrap in or write a plugin to Terraform to use the backends there and then deploy NixOps and NixOS machines. There is a project called TerraNix, where you can write Terraform specifications in Nix. But unfortunately, that's where it ends. Like you can't specify host configurations in that same configuration. It just deploys, for example, like Debian boxes or something like that. So, yeah. All right. Yeah.
So in Terraform, there's this state management thing
Mm-hmm.
where when you write your configuration, like as I understand, you kind of need there's some states in NixOps that you need on your computer, right? Like you
Mm-hmm.
can't just with Ansible just move it to another. And
No.
like how is that managed in NixOps?
Okay. So the question was that how is the state managed in NixOps? Since it keeps track of physical resources and such, it has to keep track of that somehow. And yes, NixOps creates a local SQLite database and stores everything in that. And you can export that configuration using, I think it's -- export. And then it just prints the configuration in a JSON format. But yeah, then if you want it to be like a multi-host setup, then yeah, you need to somehow wrap that. So either like what I do is just wrap the export and import thing in a script and automatically commit that to a Git repo and push it. But the more optimal setup would be to actually have proper database support, like external databases, maybe Postgres. And yeah, exactly. That would be great, but yeah, we're not there yet, unfortunately. But how am I on time? Actually, I know. Okay, good.
We'll take one more.
Yep.
I think there's one more question.
Okay. Yeah.
Well, I've seen some people using Nix on macOS. Could you
NixOps
build,
or?
you said you build local packages in your
Mm-hmm.
machine and then push it to the VM or something.
Yeah. Yep.
So can you build packages on macOS and push it to the Linux machine?
So the question was, can you build packages on a macOS machine and then push it to a Linux machine? It's a good question. I haven't seen NixOps being used on macOS, but yeah, I guess it could be done. Yeah, I'm not sure. It's yeah. So and so. I'll yeah. The main use case, I guess, is on Linux or on NixOS. You would probably use this, and yeah, maybe on other. It probably works on other Linux distros as well, because I don't see why it wouldn't if you have Nix installed. But macOS, maybe a different beast. Yeah.
I'm just going to add, it works on macOS if you set up a Linux remote builder. But you need,
Right,
you need to do
right.
remote builder, like a remote builder. You cannot do cross compilation and things for NixOps.
Okay. So yeah, like Adam added that yes, you can use it on macOS, but you have to set up a remote builder so that it builds on a Linux machine. It can't build it locally, which yeah, makes sense. So.
I have one more question.
Mhm.
You shown one of the configs where when you interpolate a path to a SSL certificate or something,
Mhm.
you use config word, but I didn't see where it comes from.
Let's see.
Is it some whisper or just argument from function?
Where did you? Oh wait, maybe this was just in the. What's?
Okay, show it in the video or something.
Let's see. Okay, where to go? There we go.
Yeah, here.
Yeah. So Yeah, so it's in the
Ah,
here you can see. So it's in config. So you access the configuration that way. And yeah, that's where it is. It's not it's a pretty long path to access it there, but but it works great. So. Oh, right.
One more question.
Mhm.
And,
Yeah.
one more
In
question.
the
Right.
AES, do you have like you specified a image? Like
Mhm.
what kind of image is that? Is that an NixOS image or?
Yes, it's an yeah, it's a NixOS base image. So I've built my own NixOS AMIs because I wanted them to be on encrypted disks, on encrypted storage. So then I had to create encrypted images in our network. I couldn't find any other way to just reuse like one of the upstream images and encrypt that. So I had to essentially build NixOS and upload that to our Amazon setup, and then copy that disk image over to an encrypted something or other. I don't know. It's a pretty complicated setup just to get an encrypted image, but that's what I've done, and I guess it's probably a pretty old NixOS image by now, but yeah, still works. So, all right, and that's it.